Okay, so today what we're learning is how to add vectors using math. Okay, so for example, if my first vector that I want to add is 32 meters per second squared at an angle of 72 degrees, and I want to add that to a vector of 41 meters per second squared at an angle of 35 degrees. Okay, one way I could do it is I could actually draw these in. So let's say this is vector 1. I'm going to draw 32, okay, at an angle of 72 degrees. Okay, and then what I would do is I'd add up vector 2 at an angle of, that's about 35. Okay, then I could say that my overall vector, okay, is this red one right here. Okay, this is what we call the resultant. Okay, so the definition of resultant is just the addition of two vectors. Okay, so step number 1 is if I want to just draw it in, I draw it in. But let's talk about how to do it with math. So 3 easy steps. Step 1, we're going to break each of them into their x and y components. Okay, so break into x and y components. Now we've already done something like this. Let's talk about the first one. Okay, let's say I have 32 meters per second squared and my angle is 72 degrees. If I want to find the x component and the y component, hopefully this is looking familiar. We've done something similar. Okay, so the x component, I'm going to have to use some trig here, and I'm going to use cosine. So the cosine of my angle equals x over my hypotenuse. So the x component of any vector equals the hypotenuse times the cosine of theta. For this particular example, the x component equals 32 times the cosine of 72 degrees. So go ahead and pause the video, okay, and figure out what that value is. You should get 9.89 meters per second squared. Now, for the y component, okay, this is opposite of my angle, so I'm going to use sine of theta equals y over the hypotenuse, or y equals the hypotenuse times the sine of theta. Again, we can just use this whenever we're trying to find the y component. So y equals 32 times the sine of 72. Again, pause. And then when you're ready, the answer is 30.43 meters per second squared. Okay, so what we did, we just broke the first vector up into its x and y components. Okay, so I want you to go ahead and pause the video and break our second vector up into these components. When you're ready, hit play. Okay, so in order to organize this a little, okay, I'm going to make another chart. You all know how I love my charts. Okay, so for my first vector, I get 30.43 meters per second squared. Yes, you do need units. Okay, the x component of my first vector is 9.89 meters per second squared. For my second vector, what you found when you paused the video, you get 33.59 meters per second squared. And then the y is 23.52 meters per second squared. Okay, so that's step number 1, is to break each of these vectors up into their x and y component. Step number 2, what we're going to do is we are going to find the total x and y. Okay, and just like you think, you just add up the whole x, you add up the whole y, and see what you get. So go ahead and pause, okay, and do this again. Okay, so you should get these totals for the total x and y. Okay, and what this is telling us, it's telling us that if I add up vector 1 and I add up vector 2, it goes overall 53.59 meters per second squared in the y, and it goes overall 43.48 meters per second squared in the x. So let's draw that out. Okay, so in the x, I go 43. It's positive 43, so I'm going to go to the right. And then in the y, I go 53. So from where I started, we're going to just go up straight 53. Now my overall vector, my resultant, starts at the origin and ends right at the end of this y. So this purple vector is the vector that I'm looking for. It's my resultant. So to find that, I know two legs of the triangle. So to find the third leg of the triangle, okay, I'm just going to use the Pythagorean theorem. So a squared plus b squared equals c squared. So c equals the square root of a squared plus b squared. So plug in my numbers, I get 43.48 squared plus 53.95 squared. Again, pause this, make sure you can do this on your own. Okay, your total is 69.29 meters per second squared. Okay, so that right there is the resultant, okay, but it's a vector. So what do vectors need? Vectors need an angle of some sort. Now, I know the opposite, I know the adjacent, so I'm going to use a new trig function that we haven't used yet this year. I'm going to use tangent. So tangent of theta equals, I'm going to put absolute value of y over x. You'll see why in a second. Okay. So to get theta on its own, I'm going to use the arctangent or inverse tangent of this angle. So theta equals the inverse tangent of the absolute value of y over x. So theta equals the inverse tangent of the absolute value of 53.59 divided by 43.48. Okay, plug that into your calculator. Should get 51.13 degrees. So my overall final answer, the thing I would box, is my resultant is 69.29 meters per second squared at an angle of 51.13 degrees. There is going to be another video, so make sure you keep watching.